So hey guys, again welcome back. Here again we are solving numerical based on time response analysis of control system. So closed loop system has two complex conjugate poles, which is given as S1 and S2. So two poles they have given, they have not given zeros. Okay, it is poles. So S1 and S2 it is given by, I'll just write it over here, S1 and S2. So given thing I'll just write over here, S1 and S2 they have given it as -2 plus or minus J1 conjugate, right? Complex conjugate poles are given. Determine the form of transfer function and the values of omega n, dp, dr, ds and mp. You have to consider it as second order system. Considering it as second order system, this is given in the question. I am not assuming. Second order system we have to consider. Okay, fine. So given thing we got, now we'll try to analyze what all things we need. Let us start with the solution. Now poles are given, right? And what is second order system? Transfer function. Transfer function is given as C of s by r of s. Okay, output by input is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. Right? This is the transfer function thing. Now here poles they have mentioned S1 and S2. Now this poles will be in the factor which is present in the denominator of the transfer function. The poles will be in the denominator, zeros will be in the numerator. So obviously it is obvious that denominator part will have the factor of poles. So S1 is nothing but, so I'll just differentiate. S1 is equal to -2 plus J1 I can take, and S2 is equal to -2 plus J2 I can take. Oh sorry, no, mistake. So minus J1 I can take, minus and plus. Okay. Now here the thing is that how to write it in the factor. See, the thing is that when you find out any quadratic equation x equal to -2, how you used to write in the factor? You used to write x plus 2 as the factor. Simple thing. Here also same thing you have to do, that you have to write it as S1 and S2 you got, but here you cannot write S1 and S2 separately, because the poles will remain as S only, because here you can see there is only one S, there is no S1 and S2, but poles are different, so you have to mention like that. But the thing is that when you solve, you have to write it as S and plus this will come here, so it will become plus 2 minus J1, one factor will be this, and here S, this will come here, it will become plus 2 and plus J1. So I hope you understood what we are trying to do. These are nothing but the factors which will be present in the denominator. Why denominator? Because poles are in the denominator. This you might have studied. Now this is in which form? If we observe carefully, it is in a minus b into a plus b. What is a here? A is nothing but s plus 2. S plus 2 is a, and b is nothing but this part, J1. So a minus b into a plus b. What is the formula? A square minus b square. So you can write it as a square minus b square means a plus a square minus b square, right? So when I simplify this thing, a plus b the whole square is a square plus 2ab, 2 into s into b, plus b square, which is 2 square. Then j square value will give me as what? This one. J square is nothing but -1, so it will become plus 1, right? J square value is -1, so outside one more minus is there, so it will become plus 1. So what is this answer? S square plus 4s plus 4, this is 4 plus 1 is 5, so it will be 4s plus 5. So this is the denominator part, r of s part. Okay, so how to write C of s by r of s? Carefully you have to understand. This is the transfer function. Here if you observe, this is omega n square, this is also omega n square. That means these two should remain same. Okay, so here this part is nothing but, as I said, it is in the denominator. We will try to analyze here. Transfer function C of s by r of s is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. You have to compare it with what? This denominator part, s square plus 4s plus 5. Okay, now this part and this part same, right? S is there, s term is there, s square is there, s square is there. So this part will be same as numerator, this part, so I can write directly 5. So though I got the value, right? Transfer function I got, c of s by r of s is nothing but this one, 5 by s square plus 4s plus 5. Now you compare. If you don't want to write, no need to write, just compare this with directly omega s square plus 2 zeta omega ns plus omega n square. Directly compare. Anyways, you will be getting omega n square value as what? 5. Okay, now we have to go for what? Comparison. So comparing, what we will be getting, first thing, that when you compare omega n square, you will be getting it as 5. That means what is omega n value? Square root of 5, right? Square root of 5 value is nothing but 2.236. Then second thing, what you are comparing, 2 zeta omega ns. No need to compare s square because it remains the same. Or 2 zeta omega ns, if we compare with 4s, s and it gets cancelled. Omega n value we already know, just substitute to 2 zeta into omega n value is 2.236 equal to 4. From this, can I get zeta value? Zeta is equal to 4 by 2 into 2.236. So it will be equal to 0.8944. Okay, so we got omega value, omega n value, natural frequency, and zeta, which is the damping ratio. Both we got. Now we have to find what? We have to find omega n value we got, TP value we have to find, then TR, TS, MP. First we'll go for TP. What is TP? Peak time. Okay, so everything we'll find out. What is the formula? Let us go for peak time. Peak time is denoted by TP. So we are having the formula TP as pi by omega d. Now what is omega d? Omega d we have to find. Omega d is equal to, otherwise we will write directly here. Okay, anyways we have to find separately omega d. Omega d is equal to square root of 1 minus zeta. Omega d is equal to omega n into 1 minus zeta square. Square root is there. Square root of 1 minus zeta square. Omega n value we already know, which is nothing but square root of 5, which is 2.236 into square root of 1 minus zeta square. Zeta value is nothing but 0.8944. This we got. Now square you have to do square. So from this I'll get zeta value, omega d value as 1 radian per second. The unit is very important. Omega d is nothing but damped frequency. Omega n is natural frequency. Okay. Now we can substitute pi by omega d value is 1. So you'll be getting the TP value as what? 3.5 value is 3.1 seconds. Next, we have to find TR. What is TR? Or we can say it as settling time. We'll find out first. We'll go for settling time. So what is settling time formula? Denoted by TS. Formula is very simple. 4 by zeta omega n. 4 as it is. Zeta value we know, it is 0.8944 into omega n value we know, which is root of 5, that is 2.236. So it is equal to how much we are getting settling time? It is 2 seconds. Okay, next we'll go for rise time, which is TR. TR value is given as pi minus theta by omega d. Now here one new thing came, theta. Now how to find theta? We have the formula tan inverse of square root of 1 minus zeta square by zeta. This is the formula. It will be in radian. Now you have to substitute the value tan inverse of 1 minus zeta square. Zeta value is nothing but we already have, it is 0.8944 square divided by zeta. Zeta value again 0.8944. So just substitute this one, tan inverse you take, you will be getting theta value as 0.4636 radian. Units very important, you have to write units. Now after this you can find out rise time, just substitute theta value. So tr is equal to pi minus theta. What is theta? 0.4636, and omega d value we already got, which is 1 radian per second. 1. When you substitute this, you will be getting it as 2.6779 seconds. Time always will be in seconds. Now we have to find the last thing, which is nothing but peak overshoot. Peak overshoot. Peak overshoot is given by percentage MP. Is the this is how we have to denote. Now peak overshoot, what is the formula? It is equal to e power minus pi zeta divided by 1 minus zeta square into 100 percentage. 100 is in the denominator, sorry, in the base part. Okay, don't multiply here 100 and come. So after getting this value, we have to multiply with 100. Now here what will happen? E power, so percentage MP is equal to e power minus pi. So I'll write it in this form. Percentage MP is equal to e power minus pi into zeta. Zeta value we have, it is equal to 0.8944 divided by 1 minus zeta square, so 1 minus 0.8944 square into 100. So you will be getting the answer as 0.1867 percentage. Okay, so it will be in percentage peak overshoot. So I hope you understood the question. Very simple question, but you need to analyze that the thing is that they have given the poles. So given the poles and they have said second order system, so I have to compare with this one and try to get the factor